Hello friends, this is the part 3 of the constraint series and today we are going to learn about the wedge block constraint. In case of wedge block constraint, we will be given this is the case, we'll be given a wedge and we'll be given a block and we have to find out the velocity components, velocity of the block and velocity of the wedge, or the acceleration of the block and the acceleration of the wedge and the relation between them. This is rather a simple variety. Let's see. Let's start from the absolute zero concept. This is a block A and this is a block B. If this block A is moving with a speed of velocity of 5 meter per second, what will be the velocity of block B? If both are moving together, definitely 5 meter per second. Definitely. Otherwise, both will not move together, isn't it? Now, suppose I am this velocity, this is moving with a velocity 5 meter per second in this direction. In this direction, this is moving with a velocity 5 meter per second. Let me do it in a better manner. This was a block, as I have shown. This is moving with a 5 meter per second. This is 5 meter per second. Now, this is block A, say, and this is block B. Now I will cut this. I will cut this portion of this block. I will just cut this. I will cut this portion of this block and make it like this. You have no problem with this because just the shape of the object is changing. Now I will put it in a plane here somewhere like this. This portion of this block is moving in a velocity 5 meter per second in this direction. And this velocity is making an angle theta with respect to the horizontal. Then what is the velocity of block B? What is the velocity of the block B? This will be the velocity that is perpendicular to both the surfaces. That is 5 cos theta. Now I think it is clear how to tackle the wedge block problems. So exactly this 53 degree I have shown here. So what is the velocity component? If this one is moving like this, and I have suppose cut it and made it a wedge and made it some incline and putting it on an inclined surface, then if it is moving with a velocity of 5 meter per second, then this block B will be this velocity component will be transferred, that is perpendicular to the both surfaces. So 5 cos 53 degree, that is 3 meter per second. Velocity along the perpendicular component of the surface is transferred. That's it. Now we have a wedge block system. This is a wedge and this is a rod. This rod is moving downward due to these constraints, and this wedge is similarly moving this side. What is the relation between AW and AR? That is acceleration of wedge and acceleration of rod. It is very simple. AW is this side, so we have to find the component of AW in this direction. AR is going this side, so we have to find the component of AR in this direction, perpendicular to both the surfaces, this surface, and then we will do AW and then we will equate them because that component is transmitted. Say this is AW and this is theta and this is 90 degree, and so this will also be theta by geometry. So if this is theta, this is AW, so this will be AW sine theta. See, this is AR, this will be AR cos theta because this is theta, this is AR this side. So AR cos theta will be AW sine theta. AW sine theta is equal to AR cos theta. This is the perpendicular component of the acceleration we are equating. AR is equal to AW tan theta. That is the relation. Simple. So that was a relatively easier topic for us. So please try to apply this in other problems, and please comment below if you have any doubts. And if you like this video, please share this with your friends, and please subscribe to our channel. And we have also a part 4 of this constraint series, and that is coming soon, so stay tuned.